Okay, when we talk about things shifting vertically here, I'm going to use the example here and just use the graph. Let's get this up here. Y is equal to x squared. Now, if you look at this one here, shifting vertically is actually an easy thing to define. Because if I look at this one here and I say, well, okay, fine, y is equal to x squared. Imagine if I do something to the function. I'm just going to call this function f of x. Okay, well, obviously, if I multiply this by, let's say, 3, if I multiply this by 3, it's going to become 3y, which equals 3x squared, which equals 3x squared, not cooperating here, 3x squared, which also equals 3f of x. In other words, everything that I do to the function, or to y, I'm multiplying by 3. In other words, if I had, coordinates here, the coordinates of this graph here might be x comma y. This one now would be the same x, okay, because I'm not actually touching the x, but it'll be 3 times the y value. So that's what's happening here. So this would be like a dilation. You can see it's a direct one here, what happens to the y. I'll just show you something else here. If I carried this through here and said, well, what if we had, y is equal to, well, what if we added 1 to everything here? Well, you're going to get y plus 1, x squared plus 1, and of course f of x plus 1. And so as I'm adding it to the outside, the important thing to see here is what happens here. You're going to get a y plus 1. In other words, while x stays constant, because I'm not touching it, the new coordinate will be y plus 1. And just to show you what this would look like, well, if I had if I had a point here on the graph, let's just say, well, the point here is going to be 0, 0. Okay. Well, this point here would become 0, the same x, and 3 times that y, which is still 0. Now this one changes. If this was on here, it's going to have the point 0 and the point, well, 0 plus 1, which is 1. So that got shifted. And in fact, this would be the new vertex. There's the old one. Here would be the new vertex. And everything just gets shifted by that amount. But that's in terms of vertical. You can see what happens here. Vertical is pretty easy to explain. You could do it with one other one here, and you can say, well, what happens if you, well, here we had a vertical dilation and a translation. What if we had a reflection? And just to show you that one there, if I have, let's say, y is equal to x squared, which equals f of x. Well, now, knowing this, if I added a negative to this, okay, and I reflected this vertically, what's going to happen here is you can see this result here is that every one will become a negative y. In other words, the x will stay the same, but this will become negative y. So, in other words, this one will now become the point. If it was from the original one, x equals 0, then y would equal 0. But if I put in another point in here, okay, and punch this one in, you're going to see what happens is you end up getting the opposite of it, or the negative y. And that's why it ends up flipping vertically. So, well, the original graph, y equals x squared looks like this. The other one, every y value now, whether it was 1 right here, 2, 3, 4, 5, will now become exactly the opposite. This is going to be facing, pardon me, it's going to be, keeps trying to erase on me here. It's going to be facing exactly the opposite direction. And of course, that's a rough sketch, pretty messy one as that. But you get the idea here. Vertical translations, reflections, dilations, they're pretty straightforward and pretty easy to explain.